Cool. Well, I just wondered, first of all, what brought people to the session? So I know I see most people are on mute, which I appreciate because that's holds down the background noise. But if you want to unmute for a second or to type into the chat and just let us know in like a sentence or two what you're interested in about this. Michael?
I took an Arduino workshop like a million years ago and just wanted to brush up on some of the fundamentals. I know it's not Arduino, but some of the circuitry is probably similar.
Yeah. I see there's some other folks. I see Rain Cloud or Max. Do you want to?
Yeah, I mean, I personally have really not that much, if not no experience in electronics, but I know that I want to get into it and kind of brush up on my knowledge and expand my knowledge because I do know that, I mean, a lot of circuitry is important in everyday life, and I do want to have some sort of in-depth knowledge or even just kind of get going on some knowledge with it.
Great. Thank you, Max. And Rain Cloud, feel free to jump in, or we'll just keep moving. Cool. We'll keep moving. All right. Well, I'm just gonna. You should be seeing Tinkercad, and just to give you guys some orientation, Tinkercad is primarily a three-dimensional design program. But if you log into Autodesk Tinkercad, and it's just tinkercad.com, there's this option at the side here for circuits. And you can create a new circuit. What's nice about this is it has a simulator, an emulator for Arduino. So you can do simple Arduino programs and test them out without having to have your own kit. Or you can do basic electronics. And Rich will go through and describe what some of these items are. But the idea is you basically can copy them over into the main screen and then start drawing wire connections between them. Then you click Start Simulation, and it will turn on the LED or allow you to push the button, allow you to do a bunch of these types of activities. What I have been suggesting is there's a book you can buy, Make Electronics, which I have found useful. And you can go in and, or even online, there's plenty of circuit examples, and you can reproduce something like this inside of the software and see what the effect is in order to just kind of get a sense of how the software works and also learn how the electronics works. So that's like my initial introduction, and I think I might be the guinea pig manipulating the components, but I wanted to turn it over to Brenda or Rich, who are the content expertise in this area.
Okay, so everybody can hear me all right?
Yep.
Okay. What I would recommend that everyone do is I'm going to broadcast my entire computer screen as a presentation, and so that I fill your screen, and you don't really need to be looking at each other because I want to use my whole screen. So if you follow these instructions, I will be able to control your entire screen with my entire screen. So here it is in the lower right-hand corner, under where all the three dots are. Go up to Change Layout. Click on it and click on Spotlight. Okay, and then after you do that, go back up there and click on Full Screen. Okay, and now what I'm going to do is I'm going to present my full screen on your full screen. And now what I'm going to do is slide this window off to the side.
Rich, we're not seeing anything on our screens yet.
You should be able to, hold on a second, let me try it again. Screen 2, share, this should do it.
Yep, that's it.
Okay. Brenda, I'm hearing your audio, so either wear your headphones or turn it down. But I'm hearing the audio coming out somewhat over there. All right, so what you're looking at right here first is inside of an oscilloscope that I had as a kid. And you can see a lot of parts in there. And all these parts are obeying basic electronic principles. There's really, you might break all the electronic principles down into two subcategories: DC electronics, which is what happens when you're using batteries, even a car battery in your car, it's 12 volts DC, or a coin battery, or 1.5 volt battery of all the different sorts, A's, double A's, C's, and D's. And then the other function is the other subcategory of electronics is alternating current, or AC. So in this, inside of an oscilloscope, both those principles are being used, AC and DC. And you see in here with those orange color bands, those are resistors. The yellow things are capacitors. Up here are tubes. Over here is a power transformer. Here is where the power comes in.
So
Again, you can see the pointer?
barely.
All right, and now what I'm going to do is I'm going to put this aside, because what we ultimately want to be able to do, hopefully, is to understand what's going on in something like this and to make something like this. There is one more category in electronics that you have to pay attention to, and it's called semiconductors. And from semiconductors, the simplest semiconductor is a diode or rectifier or an LED. And the most complicated ones are microprocessors and microcontrollers. The microcomputer world is dominated in today by a processor family called the, I'm drawing a blank. Anyway, there's what you find in your cell phones. And those microprocessors are truly, truly amazing. They're very tiny, and we're going to talk about them eventually. So semiconductors, microprocessors, microcontrollers, and then we get here, getting started in electronics. Now, so what I thought I would do first is show you a set of books and documentation that's online, or I actually own all these books. And here is the fundamentals of electronics. And so let's just take a quick look at the front cover of these books. This one is called Getting Started in Electronics. You can see it first came out in 1983, and the last edition of this copy that I have here was 1994, and it's by this fellow by the name of Forrest Mims. He is amazing. He probably did the very best electronics course that I've ever seen. Let me blow up the screen a bit. And now I'm just going to thumb down through the pages real quick. Notice he's got a cartoon. All the print is he's handwritten it all. And it's all done like this, one step at a time through electronics, through the basic principles. You've probably all seen that principle. You take an iron, you wrap a coil around it, you pass a current through the coil, and the iron becomes a magnet. This is electromagnetic. And that is what radio waves are, electromagnetic waves. But in this case, you can see that you cannot separate a current flow in a wire from a magnetic field. If you have a current flow in a wire, you have a magnetic field around the wire. If you wrap the wire in a coil, the magnetic field gets much stronger. And it will deflect compasses, and it can pick up iron. And then here's a battery. You probably, if you were in elementary school being shown electronics, everyone's into sticking two pieces of dissimilar metal and a lemon. And if you put a voltmeter on those two dissimilar pieces of metal, it'll register. You could probably light up a light bulb, light up a LED with a couple of them. I'm going to move on. I'm not going to go through this whole book. I'm just showing you that this is one of your resources. This is a really cool resource right there. Here you have on the top picture a battery and an incandescent light bulb. And take a look at the bottom. The bottom of the battery is the negative side. Top of the battery is the positive side. And you see the electrons going down along the bottom rail and then up to the light bulb, through the filament of the light bulb, and then up to the top rail to the positive side of the battery. Well, it's very important because that truly is scientifically what is going on. The electrons are moving from the minus side to the positive side. And Brenda, when she was studying the electron, she made a comment to me one day when she got to Ben Franklin. She says, Ben Franklin got it wrong. He thought the current was flowing plus to minus, and that's true. And so today, you ask the question, which way is it happening? Most people think today that they look at it in terms of the current flowing from the plus to the minus. And so in reality, it's the electrons are moving minus to plus. So what is flowing plus to minus is the opposite of an electron is flowing plus to minus, and that is an absence of an electron. That's a hole. So they often refer to it as hole flow or electron flow. And for our purposes, in my whole life, it doesn't matter. As long as you stick to one or the other, you will be able to understand electronic circuits. So let us move on and just take a quick look. Here is a battery this illustrates a very interesting point here. And by the way, this is not a schematic diagram. This is a pictorial diagram. The battery is represented by a picture that looks like a battery. And the light bulbs are represented by a picture that looks like a light bulb. So these are like flashlight bulbs. So here you see the current is flowing through 3 light bulbs. That's called a series circuit. So this is a course in electronics. So we're going to start with a whole bunch of basic principles. And we will be running this program quite regularly as JR allows. And I will dig in deeper and deeper and deeper as we go. But we're looking at documentation, where you can go to teach yourself. Now, you also know you have Google search and you got YouTube. YouTube has all this stuff is in there in YouTube. So occasionally I will go to one of those to make a point. And sometimes if you're researching and you're trying to understand things, you can go there and use some keywords and look something up in YouTube and get a pretty good presentation, usually 3 or 4 or half a dozen, probably more than you care to see, different presentations on the same subject. So as I just come down this page, another fundamental principle is where these 3 light bulbs are all connected to the top rail and the bottom rail. And I'm using those words on purpose. So the bottom rail on this is negative and the top rail is positive. In a lot of diagrams, you will see the bottom rail with a little sign on the bottom indicating it's ground. Sometimes they call this side ground. But in this case, all 3 light bulbs are hooked up in parallel. So the current is flowing, and a circuit is going like this through this one and like that. Each bulb has its own current. But by the time it gets to the battery, they all add up. So the maximum current is right there between the battery and the first bulb, because that wire there is carrying the current of all 3 light bulbs, likewise on the negative side. So this is where the fundamental principle of hooking things up in parallel. So there's a difference between hooking them up in parallel and hooking them up in series. This fundamental principle here in electronics. We'll get back to it. Let's take a look at this one. This is a very interesting circuit because these 2 bulbs on the right are in parallel with each other, and they in turn are in series with these 2 bulbs. So you got 2 bulbs that are in series and 2 bulbs that are in parallel. So the current is flowing like this. You got really 2 different circuits. One circuit is it's going this way up through that first bulb, through the 2 series bulbs back to the battery, and the other one is coming all the way out here through the last bulb, goes up, across, and joins up with the current coming through the first bulb that's in parallel. And so now you got the current in here for both of the parallel bulbs is right in between bulb 2 and bulb 3. And then they flow equally through these two. And so the current at the top of the battery is the total current of this circuit, the total current. And we'll talk more about it. So what I'm going to just flip through, no more talking about what's in Forrest Mims' book, just a quick look at various pages. And you can see he does wonderful, wonderful explanations. This guy's a great teacher, and he's very funny a lot of times. He has a lot of really clever things to say and clever ways of showing you how things work. So what I'm going to do is bow out of this now and go look at some of the other documents, other resources you have for learning. Let's see, did I go up too far? Up, back up here. That's good. And by the way, these books were published by Radio Shack. And Forrest Mims has dozens of books, just like this one, that were published at Radio Shack. You were able to pick them up there. Great book. Now, you could get this book by buying it. I own this book. I own all these books. But I also downloaded them all off of the internet in PDF format. And so I'm looking at a PDF format right here, Getting Started in Electronics by Forrest Mims. Now, what I'm going to do is switch over to this book. It's, let me see if I can, hey, I love this thing. I was just trying to get used to, doing this, and I'm a little awkward at it. So you have to bear with me as I come up the learning curve. Here is volume 1 by this guy, Charles Platt, Encyclopedia of Electronic Components. And I'm going to go down, just going to flip down through the pages. You can see, I don't know. I wonder why it's jumping so fast. Hold on a second. I'm going to try it this way. Hold it. I got to move my mouse, and I don't have room. One moment. It's an awkward moment. Okay, here we are. I'm going to just take it slow. And so as we come down, here's a whole bunch of components. I wonder if I clicked on one of them, if it would take me there. It doesn't look like it. So I'm not even going to try. I didn't see that it was a live link. So we're in volume 1. Here's what he has to say about volume 1, blah, blah. It's made, this publication comes from Make Magazine, Encyclopedia of Electronic Components, volume 1. And we'll go down the list real slow. We get to the table of contents. Here we go. And I thought I was going to be able to scroll this, and it seemed like it was jumping. I'll have to find out why it's doing that. So I'll just go real slow. Here you can see how to use the book. Very interesting. Theory and practice, organization, blah, blah. And then the first subject is power and source, battery. Where do you get power? You got to have a source of power for any electronic circuit. And so we move down. Connections, how you hook wires up to each other. Fuses, what a fuse does, it just breaks if you abuse it. It has a rating. If you go beyond its rating, it opens the circuit and protects the circuit from burning up. Then it gets into buttons, push buttons, switches, and it gets more and more advanced the deeper you go in here. So notice that one right there. There's a relay, rotary switch, push button. I just saw a resistor right here. This is something we're going to spend some time with. Let me see if I could jump. Wait, man, it jumped hugely.
So, Rich, we're at 22 minutes, and I think we are scheduled for 45 minutes. So I want to make sure we get to the simulator that folks might want to be able to try.
All right, why don't you take over, JR? Go ahead and do it. I was going to.
Okay, so I can do. Well, are you in a place where that makes sense?
Well, I had a different plan, but I'm willing to go along with whatever it is you want to do.
Well,
I just know that I cannot. I don't think it's a good idea to try to teach everything in one setting here. This is a course in electronics. I want to start with reviewing the documentation, and then we'll get into exploring circuits. So, but that's the way I would approach this.
Well, at least the way it was.
You're welcome. You're welcome to hop in.
So, Rich, well, maybe we can. I think the way it was advertised was not a course in electronics. It was more like how to build a simple circuit in the simulator. So let's, if you don't mind, let's make sure to just we can do that real quick, and then we can continue the deeper dive, perhaps.
Well, I had this. I was into the basics of it, but okay, that's fine. Take it away.
Yeah.
You got it?
Right. Yeah, I got it. So what I was hoping that you could, help me understand the parts of was reproducing a circuit. This is one I'd picked. And we can try to come to an understanding of it.
That's an upstairs, downstairs switch arrangement for a light bulb. You turn it on the bottom of the stairs. You turn it off when you get to the top of the stairs. And likewise, when you're coming down the stairs, you turn it on from the second floor and turn it off when you get on the first floor. That's what those two switches are doing with that LED.
Okay. So yeah, so I'm just going to try and grab the different components. What type of battery was it? 6 volt. So I know that you can make, all right, and then switches. Does not have a similar looking switch, huh? So I wonder. Well, I suppose
that's slide switch.
What it looks like, right?
Yeah, you need 2 of them.
Okay, so I'll bring the 2. All right, and then I think we needed 6 volts on the here, so that means I need more batteries, right? So 3 batteries. No, now I need 4 batteries, right? To make it.
You could light it up with 2 batteries, but you would have to adjust the value of that resistor by change. If you use 2 batteries to change this value of this resistor, and you'll be able to light it up. What you want to do is don't run too much current through the LED, because that'd burn it out. This resistor keeps the current from being too high in the LED. So 3 volts is plenty to light up an LED.
Okay. So I'm going to try to reproduce the circuit, and then we'll make our adjustments, right? So I guess the hot end goes to the red goes there.
Why don't you zoom in closer to those switches? Yeah.
Yeah. All right.
So the big thing about understanding those switches is when you look at the switch in that other diagram, it was pretty easy to see, but there's got 3 wires on here. One of the wires is a common. So let's assume it's the middle connection. That's common. And then when you move it to the left, the middle connection connects to the left connection. If you move the switch to the right, it connects to the right connection. And they all have names. So the way this one, if this is the normal, the middle one is C, common. The one next to it is NC, normally closed. This one on the right is NO, normally open. And what you want to do is you want to connect them, those normally opens together and normally closed together. Then you're left with a common right there in the middle. There's 2 commons. And then that's where you hook into the LED and the power supply. Then you'll have 2 switches that control the LED.
So I know I go from the resistor to the LED, and there's these 2 legs, right? So the resistor, it doesn't matter what side I hook to, but I have to hook to, what side would it be? Would it be the anode?
It definitely would be the anode if you're coming from the positive side of the battery. The anode, see, this is one of the problems with something like this. You don't really see what's inside this little red dot. What's inside this dot is a diode. It's got a bar and a large arrow touching it. And the large arrow is the anode, and the bar is the cathode. So that left side is the cathode.
Yeah, so I see there's a little squiggly line to indicate, and then you have the cathode, and then I see that the LED has a cutoff on the side, which is typical. The LEDs will normally have an indent indicating what side is negative, right?
Yeah, it's a flat side, and it corresponds to the flat side of the schematic diagram, which is the cathode is just a flat bar.
So this connects to the middle, right?
Right.
All right. And now
you could rotate that lower switch, put it right underneath it, and rotate it.
Yeah, how do oh, right here, huh?
Yeah, keep rotating. All right,
Cool.
now slide it over. Okay, now you can just connect the outer ones together.
So yes, so it's both the outer. All right, now
you only got 2 more points to connect with a single wire.
Yeah, okay. Obviously. And we have to set the resistor, right? The amount of resistance.
So let's look at that resistor. It's brown, which is 1, black, which is 0, and then 2 more zeros. The red indicates 2 more zeros. So you got 1, 0, 0, 0. You have 1,000 ohms. That's it. So that's
cool. Yeah, and it says 1,000. It says K, and then like ohms. So I'm assuming that's
well, if that's
ohms,
red, it's 1,000. If it's orange, then it is. Yeah, it's 1 k ohm.
Yeah. So what are they recommending in here?
That's close enough. That'll limit the current down to 3 volts at 1,000 ohms. You'll limit the current to 3 milliamps. So that's fine for the. Those LEDs can handle those. Typically, they're designed to operate on 20 milliamps. But nowadays, they're all over the place. But most of the LEDs that you find to play with will operate beautifully at 20 milliamps.
So I should be able to start this circuit. And I guess you can predict what will happen, right?
Well, all right, let's take a look at the top switch. So the top switch is closed. So the wire, the current goes in the middle wire of the switch and comes out the wire on the left. So then it comes down to the lower switch, and that switch is open. So the current is not going to be connected to the battery. You have to flip that switch. Flip the lower switch. Then you will be able to have the light will come on. You have to click on the switch.
All right. Well, I'm going to simulate it. And you're correct. You can see it's a little subtle, the light, but you can see that turns it on and off. I wonder if another color shows up better.
The practical significance of this is a very common circuit, and you see it all the time on your stairway. You ever wonder how you can turn the light on at the bottom of the stairs, and then when you get upstairs, you can flip it off with the switch upstairs, and then later on, you want to go downstairs, you flip the switch upstairs, the light comes on, you come down to the bottom of the stairs, you flip the switch, the light goes off. And that requires, this switch is a single pole double throw switch. It's got a common, normally open, and normally closed. It's double poles. It's got 2 poles, the normally open, normally closed. So if you were to look at what's going on between the 2 switches in the wall, you're basically got these switches are connected by 3 wires. And that's what makes them be able to do what they do so cool. It's a really cool design.
Yeah. So just to kind of get my head around it, so I can think of this little switch area is where it's bridging these 2 connections.
That's right.
So the electricity is coming through here, crossing this little bridge, and it's getting here, and then it's crossing this bridge and coming back down.
Right.
But if I move the bridge over, now it's broken here.
Right.
Right. But then over here, so if I move this one over here, now the whole thing is going through this alternate channel.
Right.
Okay,
So
I actually never
why don't you
knew
why
how a
don't you
double throw
trace
switch worked
why
before.
don't you trace the current flow in both circuits just by moving the arrow around and take a look at where the current flow is.
Cool. Yeah. All right. Well, I've done a circuit here, Rich, which was my primary objective with showing folks how, and obviously the wires, and it naturally demonstrated it. Is there anything that you wanted to add to this or try?
Yeah, I'll have you
or
add it.
mention,
I'll
or
have
we
you
could.
add it. I'll
What was
have
that?
you take out a meter. Go down the strip on the right and find a meter. Keep going.
Uh-huh.
Keep going. They're down there. Keep going.
Oh, I'm in switches. Multimeter?
Yeah, drag it out when you find it. All right. All right. Now just leave it right there for now. And connect those two wires to the two wires on the battery. The two the black and the red to the black and the red. That's it. Just, yeah, that's good.
Okay.
Now turn the simulator on.
Oh, cool. I didn't really, yeah.
All right. Now drag out another one.
Another multimeter?
Yep. Take out another one. And this time, hook those, the black and the red to each side of the resistor.
Okay. Does it matter which side?
We'll find out in a minute, but yeah, it does matter. And if you get it right, it'll give you a nice positive number, or it'll give you a negative number if you get it wrong. Go ahead and turn the simulator on. All right, make the circuit operate now. Click the switches.
Oh. Oh yeah, okay.
All right, now you got a negative number. So take those two wires off that you just put on there and hook them up the other way. You just gonna have to. Well,
I have to erase that wire and
yeah,
then
just click it off. Yeah. Okay, now turn the simulator on. We're not done yet.
Okay, so I need to make it. So yeah, so 1 point. So I have a voltage drop because the energy went into the light bulb.
All right. Well, we'll talk about that.
Oh, no, it didn't. It's going through the resistor.
Yeah. Meter. Bring out one more meter and put it right underneath where it says 1.17. Off to your left. Yeah, right in there. Okay. Now connect that one to the LED. The same way you just connected one. Yeah, go ahead.
Yeah, so that's the positive, and that's the negative.
Okay.
Now, color code these wires.
Now click on the white space to deselect those wires. Now, whoops, something's wrong.
No, I was just making the wires white so that they look different, but it's fine.
Okay. Go ahead and turn the simulator on now, and then we'll take a look and see what we have.
Millivolts. Oh, because that's the difference.
Make the circuit, make the light bulb turn on. Turn on the LED. All right, stop right there. And get rid of that. Yeah, that's good. All right, wait, the circuit's not on.
Oh. There you go. Circuit's on.
Now let's just pay attention to what we're looking at here. So you have 3 volts for the battery, and then you have 1.7 volts across the resistor, and 1.83 volts across the LED. So the LED has 1.83 volts on it, and I can tell by that number where in the rainbow the color is going to come out, what color that LED is going to shine at. It has so the photons that are coming out of that LED are going to be 1.83 volt photons, and that's a little bit less than 2 volts. So it's going to be in the yellow-orange range would be where it fits in the rainbow. If you look at the rainbow, but if you add these 2 voltages together, now this color here is probably not true, but if you add those 2 voltages together, it should add up to the voltage. Now that's an error. Just stop right there. That's where I was taking you. I was going to show you why there's an error in the simulator. But turn the light on again. Okay, so what happens if you add those two numbers, 1.17, 1.83? Does it equal 3?
Yeah.
Okay, this is in electronics. It's called Kirchhoff's law. So you start off on one side of the circuit, you got 3 volts. And as you move around the other circuits, the voltage drops in smaller and smaller amounts. But the total of them all add up to the 3 volts. Now turn the switch off. All right, now look. Here we have an error in this simulator. The simulator is not working right now. It's still reading 3 volts on the battery. We haven't changed the battery. Of course, it's going to continue to read 3 volts, but it's showing 58.3 millivolts across that LED. And there's no way that can be there because the circuit is open. There's no current flowing in that circuit. So the simulator here is making a mistake. I noticed this the other day, and you can see it right now. So it's showing a voltage across the LED, but if you were to actually wire this up in the real world, that would not be happening. So that was one of the points. But this is where you can experiment. This is actually a pretty cool little circuit. You know, it's a cool web page where you can explore a lot of electronic circuits with this.
Great. Well, thank you for walking me through that, Rich. I think perhaps people have some questions about what we've covered so far, but once you've addressed those, we can jump back into some more of the fundamentals. I just wanted to make sure that folks got a walk through the electronic simulator portion of it.
Yeah, I was going to get to this, but I did want to go over the resources that one has available to them to learn electronics.
Yeah. Did you want to jump to questions for a moment, or do you want to go back into?
Sure.
Yeah.
Fire away.
Any questions?
No questions or questions?
Sometimes it takes people a second, but I guess there's no questions for now.
Okay.
So I'll let you go back, and
all right. I'm going to go back to my presentation, and I found out I learned another thing why the pages were jumping around in here. So that won't happen again. So let me go to present now, and when I do present now, I can present one of my windows, and I got about 5 or 6 windows open here, but I'm going to present my entire screen. Here I go. And I'm going to choose, I'm looking on a window that says, which screen do you want to present, Rich? I got 2 screens up here, and I'm going to click on screen number 2, share it. And then I'm going to take this screen and move that window and put it over here. So now you should see my screen again. And so I'm just going to run through these documentations really quick. And I found out that as long as the whole page is here, I can scroll up and down this. This is really what I was trying to show you before. I'm just trying to give you a fast view of this wonderful book, an encyclopedia of electronic components. And you can see it's got a great table of contents. I'm not going to spend more than I'm going to jump way in. And it's going to go through all kinds of cool circuits. When you finally get to resistors, it'll tell you everything you want to know about a resistor, everything you want to know about batteries, connectors, wires, diodes, fuses, capacitors, relays, motors, push buttons. Here's the inside of a push button. And all right, so I'm going to close. I'm going to go back up to the top. And I'm going to put this one away. And I'm going to take encyclopedia number 2, same thing. So there's 3 volumes. And now they're starting to talk about some interesting components, alternating current, semiconductors, and how they operate. And all of this is, if you look things up, it's really, really well done. So this guy is going to go down in history. One of the best books. on electronic components. You can go any component, look it up, and that's took a volume 3. Same
So
thing.
Rich, somebody wrote in a question, which was, where can you get these books, and are they available for free?
Okay. Yeah. Okay. The books, if you go on Amazon or on eBay, you can buy these books. They'll send them to you in the mail. And I did do that, and I own them. But also I started looking around, and I found that every single one of these books that I'm showing you is on the internet in a PDF format that you can download. But they're not mine. I cannot give them away. I feel wrong in giving them away, but I don't feel wrong in telling you I did find them on the internet in PDF form. And that's what those PDF forms are on this screen right now for the Encyclopedia of Electronic Components. And you can access them on your computer real easy when the time comes that that's what you want to do. So my recommendation is Encyclopedia of Electronic Components. Look it up and find a place where you can download it. And but don't tell them I told you that, because I don't know if that's legal or not. Anyway, so I'm going to move over onto the other side now to another set of great books from the same people, Make Electronics, and by the same guy. And here is, he's telling you your basic tools, your VOM or a multimeter that measures volts, amps, resistance, and some of them go beyond that, measure other things as well. Some could measure temperature. Some could measure transistors if the transistors are working properly. And here's an interesting resistor that you're going to see a lot. Here's some LEDs. And this resistor, notice it's got 3 wires on it. So if you go to the outside wire, the 2 outside wires, it might measure on an ohm meter of 1,000 ohms. But in the middle wire, there's a wiper. And as you rotate this, the wiper moves from this side of the resistor all the way down to this side of the resistor. So the wiper is variable. It moves. The value of the resistance from one side to the middle will change as you rotate it. But the value of the potentiometer or the variable resistor is constant from this side to that side. But from any one of those sides to the middle, it depends on where you have it turned. And you'll see this is used quite a bit. And you can simulate this. That resistor you just had in the LED circuit there that we were playing with, if you put one of these in there, you can adjust its brightness.
Can we try that?
Go right ahead. I'll let you do it, okay?
All right.
Take it away.
All right. So I'm going to take... Oh, stop simulation.
I need to get out of... Okay, yeah, there you go.
Yeah, so I'm going to get rid of that.
Delete all that stuff.
Maybe I have to delete the wires first.
Yeah, so what you want is a pot, an LED, and a 3-volt battery will be fine.
All right. Potentiometer right here.
Yeah. Oh, yeah, you could just substitute the potentiometer in there for the resistor.
Yeah, was there another way to do it that I was just not...
All right, no, that's good. That'll work.
We can rotate it. All right. Put that to the side. Connect some wires. So I want one to be the wiper, right?
Yeah.
Does it matter which one?
It matters depending on which way you want it to get bright, if you rotate to the right or rotate to the left. But either way, you got to be on the center one. The outside one is a choice you have to make.
Okay. Let's try. I mean, I disconnected the multimeter, but...
Make the light up first.
Oh, yeah, because I got these switches on it. Okay.
All I do is flip one of them.
Oh, I just broke it. It shows me breaking it.
Yeah. So let's talk about what happened there. Keep going until it lights.
I think it is.
You blew it out. That's cool. That's cool that you did that. All right, turn it some more.
All right, so I'm going to turn it on. So it's going through pretty dim. So it's showing dim.
Well, keep turning it until it brightens up.
And it just,
See. All right.
there's
So
like a
look
very
at-
low, like as soon as I get there, it gets bright and then it blows up.
Stop just before you blow it up. All right, so we'll go back. All right, let's take a look at what happened. Why did you blow it up? So if you consider that the potentiometer, the wiper, is almost touching that outside wire now. So the current is going in and out without going through much of a resistor. And that, so what happens is basically when you get all the way to the end, the whole 3 volts is being applied to the LED, and it doesn't like that. Because
Yeah,
the
I
LED
should actually put the resistor in front of it, right? So that what the potentiometer is getting is already limited. Yeah? No?
Well, you can try it. So take that out, put the resistor in there. Of course, now you got 2 resistors in, so you can move the resistor up, drag it right up and right where you can see it nice on the screen. Yeah.
Okay, I'm going to make this white so it's clear that it's just testing.
Now turn the pot up all the way to where it was blowing up before.
Yeah, I think I have to turn it on. Oh, look at that. I can change resistance in the pot too. All right. So it's got nothing. Oh, I have to turn it on. Duh. Okay, now it's on.
There, now you can see the voltage is changing. Remember, they always got to add up. Those 2 on the left have to add up to the one on the right.
But I don't blow it out, and it goes all the way. It goes bright now.
Yeah, and the one thing is that let's talk about the LED. The LED only passes electron current in one direction. If you hook it up wrong, it will not light up. The current cannot get through the LED in the reverse direction. And there is a limit to the amount of current that you can allow to flow through this LED. If you make too much current flow through it, it'll get hot and it'll burn out. So that's why you put the resistor in there, because the resistor limits the current in that circuit. And there's a simple formula that expresses this called Ohm's law, which is another fundamental principle, but we're not dealing with that right now. So that is basically what's happening there. So you're adjusting the voltage on the LED by turning that pot.
Now, if this pot was a different resistance, I would probably get a different, it would brighten sooner, right?
Yeah, exactly.
I turned it down like 100 or 50, 10.
Well, you can experiment with that. I think if see what it does.
So I would predict that it gets brighter sooner. No. Oh no. Okay, hold on. Oh yeah. Well, it's like bright the whole time pretty much.
Yeah, there's a ratio there between the 2 resistors, between the pot and the fixed resistor. That's being able to predict that in your mind's eye without knowing Ohm's law and understanding it might be a little bit difficult. But basically, here, one of the things that there's another way to do this. You want to try something cool?
Sure.
Delete everything except for the battery.
Let's stop the simulation. All right.
Okay, bring out a pot. Set the value of the pot to, let's take it up to 1,000 ohms.
Okay.
Okay, now hook up the 2 ends of the pot to the 2 ends of the battery.
So the 2 ends being the middle or the actual side?
The ends. Yeah.
The ends. Okay.
Okay. Now set the wiper in the middle of the rotation.
I think we have to start simulation, don't we?
Yeah, I guess you do.
Okay. All right. Set it.
Let's just leave it in the middle. All right, that's fine. Now hook up a voltmeter to the red side of the battery, red to red, and then negative to this wiper, to the
Oh, to
wiper.
the wiper.
Yeah. Okay, put on simulate.
Okay.
Now move. There you go.
So I get
So
my
you
full
can
3
see-
volts there.
There you go. Now you have variable voltage off that wiper. And here's a very interesting thing: is these LEDs. If you're going to guess, if you know, let me help give you a rough concept. If you're going to guess the right voltage for an LED, it really helps if you know the color of the LED. Then you could probably nail the voltage exactly. But it's going to be between 1.5 volts and 3 volts. So 2 volts, if you set it around 2 volts, a 2-volt LED is going to come out red-orange right in the middle of the rainbow. So if you had a red-orange LED, it's going to want 2 volts on it. And that's when it will work the best. So you could, instead of that voltmeter, you can hook an LED, or you can hook an LED up to that voltmeter right now.
So I also had another question. I see I can change the multimeter to resistance or amperage.
Yeah, well, let's just whoa. This is
That's
knowing
more advanced. All right, I'll leave it. I'll grab the LED.
if you got battery power turned on, which we do, you do not want to put that in R mode or resistance mode. That'll wreck the meter.
Well, it's simulated.
You could
Yeah, it did. It errored the meter.
Put it in amps, and now rotate. Put it in amps and rotate.
What do you? Oh, rotate the.
Okay, somehow there you go. That's maximum current, 2 amps. That is like almost that is, and then you can see smaller and smaller amperage as you increase the resistance.
Okay.
All right.
So I'm gonna stop, and then I'm gonna add the LED.
Yeah.
And what do you want me to do?
Just hook the LED up to the voltmeter.
It's a voltmeter.
Yeah, that's good. Oh, actually, do we have it in reverse? No, we're okay. All right, simulate. Change the meter to volts. Yeah. Now move the pot around until you get the LED to light.
Oh,
there. That's too much. That was too much voltage for it.
Yeah, it's somewhere around here, but I think
this simulator is not doing a really good job. If that was a real LED, you would see it glowing at a lower voltage. And
yeah. Well, I think it's just it doesn't show it glowing. It's not too crazy in animation, but you can see compared to the here. I'll put a regular LED beside it. So you can see it's on.
Yeah, and then it should be changing its brightness, and it really isn't. The simulator doesn't do that good of a job of doing that.
Yeah, could be brighter.
But let's talk about the potentiometer. As you know them as a volume control, as a tone control, and they also have another name. They're called POTS, P-O-T for short for potentiometer. They're also known as variable resistors. And what's coming into vogue these days, I hear it being referred to, I was kind of miffed by the notion, but people are calling them VRs. To me, a VR is a voltage regulator, but people are calling these potentiometers as VRs, meaning variable resistors. So it's a resistor whose value you can change. And you know, the interesting point is there's a center position, and you can go one way and increase the resistance and go the other way and decrease the resistance. So that's pretty cool. So your tone control, you know, you have the tone control in the middle. It's not adding any bass, or nor is it subtracting any bass. But then if you turn it to the right, it's adding bass. And if it's a bass control, or if you turn it to the left, it's subtracting bass from the audio signal that you're listening to. Variable resistors are a fundamental part in the electronics world.
Cool. Well, that's
so
helpful.
What I was thinking is the next time we do this, I'll just keep digging in a little bit at a time. Tune in if you're interested, and I will have something to demonstrate it every time we do this. And so we will just dig in further. We'll look at another simulator. There's a couple simulators. This is one of them. We can always be going back and forth between the two and see how they work. So that's my thought, JR. I hope that works for you. We can do this again, and the next time we'll go in a little bit deeper.
Yeah, I think it's good to have a little theory and then some demonstration or practice that people can replicate at home. At least for me, that's a method that works well. So I thank you for being flexible with that. And it sounds like you're ready to wrap up. We are close to that hour.
It's fine with me.
Yeah.
And you just schedule for the next one, and we'll take it from there.
Okay.
And
Great.
Every time we do it, we'll go a little bit further.
That sounds good. And I'm of course willing to have somebody else be the guinea pig controlling if that's if somebody's excited about that and you're excited. So we can keep it flexible. All right. Yeah. So thank you, and I see some thanks coming through on the side. Unless there's any other questions, that's good.
Okay, great.
Thank you. I will stop the